So okay, I think you can able to see my screen. So we are going to start the topic that is motion. So what do you mean by motion? Motion is nothing but the movement of an object with respect to time. For example, I'm standing here. Okay. After some time, I changed my position to here. Okay. So in a particular instant of time, I change my position from here to here. Okay. So it might have taken just 1 second or 2 seconds. So my position has changed in a particular interval of time. So this itself we call it as motion. Okay. So suppose a pen is here. Okay. I threw the pen. Okay. It went up and it came down after some time. Okay. So here also position of the pen had changed in a span of time. Previously it was in my hand. After few seconds it went up. So here also the position has changed. So this we call it as motion. So we have various types of motion. So how do we define motion? So we can say like this: motion, motion means movement of an object, okay, with respect to time. Okay. So motion, how do we define? Means it is the movement of an object, okay, with respect to time. Okay. So we have various types of motion. Some motion are very simple and some motion are complex. So here we are going to discuss a special type of motion, that is motion in a straight line. Okay. So motion in a straight line. Okay. So what do you mean by motion in a straight line? If the motion in is in one direction. Okay. If the motion is in one dimension. Suppose I have a pen here. Okay. If the pen is moving in this horizontal direction, or if it is moving in vertical direction, okay, we call it as motion in a straight line. Either it may be horizontal motion or it may be vertical motion. Okay. So similarly, we have another type of motion, that is circular motion. Circular motion. Okay. So you might have heard that Earth is revolving around the sun. So how does Earth moves? Means in a circular way. Suppose this pen is moving like this. Okay. So this type of motion we call it as circular motion. Similarly, we have another type of motion, that is vibrational motion. Vibrational motion. So what do you mean by vibrational motion? Means every matter, okay, suppose this pen is, we consider it as a matter. Every matter is consist of atoms. Okay. So atoms vibrate itself. Okay. So we call it as vibrational motion. Similarly, our body is also made up of matter, and our body is made up of what? Our body is made up of cell. Okay. Inside the cell we also have atoms, and the atoms continuously vibrate. Okay. So we call it as vibrational motion. Okay. So there are various types of motion. um, some are very simple, some are very complex, which are difficult to understand. So here in this chapter we are going to discuss all the motion which are in a straight line. Okay. So now remember one thing. Okay. So the motion is always described with respect to observer. Okay. So we can write it as the motion is always described with respect to observer. Okay. So suppose I'm going to give one example. Suppose you are standing here. Okay. Suppose you are standing here. You will see that a bus is moving. Okay. A bus is moving. Inside the bus there are so many passengers. Okay. So, inside the bus. Oh, inside the bus there are so many passengers. So according to you, okay, according to your perception, according to your thought, what you will think that a bus is moving along with the passenger, means the passengers also moving with the bus. Okay, you'll think of like this. Okay, so this is your view, your point of view, your perception. But suppose this is a person A, this is a person B, and this is a person C. Okay, inside the bus. Okay, according to person A. Okay, according to person A, the person A will think of like this. Okay, B and C are in rest. Okay, they are not in motion. They are sitting in their position. Okay, so here your perception and the passenger, which are those who are inside the bus, their perception are different. Okay, so that's why we call it as motion is always described with respect to the observer. Okay, so this thing I want to explain you. Okay, so always remember the motion is described in terms of distance. This motion is described in terms of distance, displacement, velocity, speed, acceleration, and many more. Okay, so we're going to discuss what is distance, what is displacement, what is the difference between distance and displacement, all those things. Okay, so what we have learned means motion in a straight line and how motion is described with respect to one observer. Okay, now we're going to discuss what is distance and displacement. Okay, so suppose I have a ball here. Okay, and I threw the ball to downward direction and the ball will come here. Okay, so here what happened, the position of the ball is changed. Okay, so if I will ask in how many ways the ball will change its position. Okay, so the ball will come like this, the ball will come like this, the ball will travel a long path and will come like this, the ball will come like this. These all are different types of path. There may be n number of paths a ball can travel from its initial position to final position. So the path length we call it as distance. Suppose this is path A, okay, this will path B, okay, this path A, path B, these all are called distance. Okay, so distance is nothing but the length of the path. Okay, so distance means and displacement. So distance means the length of the path. Okay, so there are n number of paths a ball can travel from initial to final position. What do you mean by displacement? So displacement is the shortest path, the straight line path. Okay, so displacement means the shortest path. Okay, uh, that is always in a straight line path. Okay, that is always in a straight line path. Okay, so now students, see, displacement is also the final position minus initial position. Okay, so suppose delta x is equal to xf minus xi, we can write it like this. Okay, so displacement means the final position minus the initial position. Okay, and distance means the length of the path. Okay, next distance is, okay, described by magnitude only. Okay, while displacement can be described both direction and magnitude. So what do you mean by magnitude? Okay, so if I will ask what is the magnitude, what is the size of this pen? Okay, so we'll just simply measure from here to here. Okay, so distance is described only by size. Okay, if I will ask the magnitude of the size of this pen, suppose the pen is in this horizontal direction. Okay, the size will be 10 centimeters. Suppose if I will ask what is the distance of this pen if it is in vertical direction, so the size will be same, that is 10 centimeter only. If it will be in horizontal or if it will be in vertical, the size will not change. Okay, the size will remain same. So distance is always described by magnitude only. And displacement, okay, will say like this, 5 meter per second towards north direction, means it is not distance, it is displacement. Okay, so displacement is always described by both direction and magnitude. Okay, but distance is always described by magnitude only. So student, so distance is a scalar quantity. Means scalar quantity means the quantity which is described by magnitude only, and displacement is a vector quantity, means the quantity which is described by both magnitude and direction. Okay, that's why displacement is also a vector quantity. Similarly, force is also a vector quantity. Okay, force is a vector quantity. Suppose I have a door here. Okay, there is a handle here. Okay, so if I will open the, suppose this is the door and this is the handle. If I want to open this door, so I need to pull the handle in this direction towards me. So here the direction matters as well as how much amount of force I need to apply to open this door is also important. So how much force means the magnitude of the force and which direction I need to open so that it will open immediately also I need to consider. So here both magnitude as well as direction matters. That's why force is a vector quantity. Okay, so distance is always greater than and equal to displacement. And one more thing, uh, displacement. And one more thing is that distance can never be zero. Distance can't be zero. Okay, but displacement can be zero. Okay, so I have to explain this two statement by giving some examples so that you can understand how distance is greater than and equal to displacement, and how distance can be zero but displacement cannot be zero. Okay, so suppose there is a scale here. Okay, suppose this is the starting point. Oh, suppose next 10, 20, 30, 40, 50, 60. Okay, so this is 10, next 20, 30, 40, 50, this is 60. Okay, suppose I'm standing here. Okay, so what I will do, I'll move from my position is suppose O. I will move from this starting position to here. Okay, suppose 60, suppose to 60 meter. Okay, so if we ask what is my distance and what is my displacement, so what we will say, so distance is nothing but the path length 0 to 60. So 60 meter is my distance. If I'll ask what is the displacement, okay, displacement means what? Final position minus initial position. Finally, I will be here in 60 meter minus initial position is 0, 0 meter. So 60 minus 0 is 60 meter. So here what we'll see is that distance and displacement is equal here. Okay, so 60 meter is my distance and displacement is 60 meter. So suppose next situation, suppose this is my initial position 0, 1, 2, 3, 4, 5, 6, 10, 20, 30, 40, 50, 60. So this will be my final position. Suppose from initial position, I will start moving to 60, then I will be going backward. Suppose here. Okay, I will be here. This is my final position. Then I'll ask what is the distance and what is the displacement. Okay, so here student, what is the distance means 0 to 60, again 60 to 30, So 90 meter is my distance, but displacement is, this is my final position, and this is my initial position. So this total length means 30 minus 0. Final means 30 meter and initial is 0. So this is 30 meter. So here what we observe, that the distance is always greater than displacement. Okay, so similarly, suppose this is my starting 10, 20, 30, 40, 50, 60. Suppose I'll move from here to 60 meter, and then again I will come back to my initial position, that is 0. If I'll ask what is the distance and what is the displacement, then what you will say? So distance is 60 and again 60. So it is 120 meter, while displacement means 0. Starting position 0 and end position also 0. So final minus initial position, final means 0 meter minus initial again 0 meter. So this is 0 meter. So here distance can never be 0, but displacement can be 0. Okay, so we got that point, that is distance is always greater than and equal to displacement, and distance cannot be 0, but displacement can be 0. Okay, so we understood here what is the difference between distance and displacement. I think you can able to understand the basic part of motion. So in the next class we'll discuss more about the chapter. Thank you.